Let's have a little lesson on cartridge brass anatomy. At the top we have the case mouth. Just beneath that is the neck. The neck-shoulder junction is where the shoulder connects to the neck. And then we have the body-shoulder junction, where the body connects to the shoulder. Moving down the case, we have the case web, which sits right at top the case head. The case head is comprised of the extractor groove, the rim, and the base of the case, primer pocket, and flash hole. When we refer to headspace, we're measuring a point between here on the shoulder and the base of the case. During the course of hand loading, it's important to understand the various places to measure, and we call those datum lines. That's essentially just the point on a specific location on the case where we're going to measure. The neck, typically the top and the bottom, often tend to be roughly the same. And so you can measure the neck diameter nearly anywhere along it, but there can be some differences from the top to the bottom of the neck, depending on the kind of sizing dies that you're using and the technique that you're using in setting up your sizing dies. The shoulder datum is typically dependent upon the diameter of the tool that you're using to interface the shoulder. The important thing is that we be up on the shoulder and not on the neck-shoulder junction or the shoulder-body junction. Some of these places are not very well defined in that the case web can occupy various lengths depending on the length of the case, but it essentially dictates the portion of the brass where the case head is coming together with the body. As it pertains to the diameters that we can measure on the case, and that is how we determine the relationship between this brass and your chamber, as well as this brass and some components like bullets, we want to measure them in a uniform place. We don't want to vary our measurements. So for instance, if we wanted to measure loaded neck diameter, we would want to measure that at roughly the same place each time, or develop a process where we measure along the entirety of the neck to gain a better appreciation of the average loaded neck diameter. Another diameter that's important to measure is the case just beneath the shoulder. So you'd measure the body diameter just beneath the shoulder, and then the body diameter down just in front of the case head, basically on the web of the case, which is the last area that's supported by the chamber. These diameters can be very important in evaluating your sizing die to make sure that you're not overworking your brass. They will also be a somewhat of an indicator of an overpressure round. Think of your brass as a moving, living thing, because it is. It moves around a lot. And typically speaking, the brass will move less down here in the harder, thicker portions of the case. As you approach the top, it'll get thin and it will tend to move a lot more, and it's also softer up here. So those of you that have ever trimmed your brass, you know that, hey, it's growing. Every cycle, every time that you fire it, it's being subjected to extreme pressure that is causing it to get squished up against the bolt face. The base of the case gets slammed against the bolt face, and it grows out as a result of the pressure squeezing on the brass. So it pops out against those chamber walls and gets squeezed really hard, and that causes it to grow a little bit. Then we take it and put it into a sizing die, and the sizing die is smaller than this is. So when we squish it up in there, we're constricting it on the diameter, and that is causing the brass to flow up and out. And so this principle of the brass moving and flowing in that way is critical for you to understand, because knowing why, when you have heavy bolt lift, you have to throw your brass away is very much rooted in the fact that the brass is flowing. It is moving around, and I don't mean just growing a little bit. If we were to fire this case 50 times, if the brass is relatively soft, we could trim as much as 50 or 60, sometimes even 70 thousandths of length off of it. So there's a tremendous amount of material flow in cases that are not very stable. Now, some companies make brass that's very stable. Other companies, not so much, despite the fact that the brass will take the work and you can get maybe equal velocities. You would never get equal velocity for as many firings. And that's a very critical thing to understand as well. The brass itself, from each manufacturer, the alloy that's used, the drawing process that they use, and the technique that is used to create the brass is largely the thing that determines how this brass flows, how stable it is going to be from firing to firing, and how uniform it is across the batch of cases. So think of your brass as very much a fluid situation, because it doesn't matter what manufacturer or model of brass you have, it is more the batch of cases. Now, every manufacturer has the capacity to put out great brass. Every manufacturer has the capacity to put out bad brass. There are some manufacturers that will produce great brass as a habit, meaning their brass is typically going to be extremely good. Their probability of having a bad batch is very low. Now, the two companies that I'm referring to are Alpha Munitions and Lapua. Now, Lapua has been in the game for a long time. Everybody knows their name. That company has historically been the purveyor of the best brass that you can find. And why it's so important that we have good brass, we'll continue to get into later in this video. But just understand that all brass manufacturers are not alike. Some of them have a high probability of turning out cases that are just not very good, not very uniform, and that lack of uniformity will often lead to further case stability problems across the batch of cases that you're working with over time. The more firings and sizing cycles that you subject that brass to, the worse it is going to drift from the mean. Well, what do I mean by that? Okay, as the brass is subjected to these firing and sizing cycles, it will be flowing, it will be moving. And this flow and movement is largely going to affect your point of impact that you see when you're shooting. If the brass is very uniform and flows very uniformly, then your firing to firing stability will stay uniform as well. That means if the brass isn't growing exponentially during each cycle, it's going to be more stable than brass that is softer and more readily to flow and growing more each firing. So this depends upon the cartridge design, because if you have a very shallow shoulder angle, which the shoulder angle is very shallow like so, then that will encourage brass flow. So dated cartridges that have that design where you've got like a 22-degree shoulder angle, cartridges like 243 Winchester, 260 Remington, 22-250, cartridges that were very popular once upon a time and oftentimes still are among the general shooting public, but their design is not modern in the sense that that brass is going to grow and flow a tremendous amount. Whereas newer cartridge designs that have a 30-degree, 35-degree, or 40-degree shoulder angle will resist that flow and movement tremendously better. And so they will grow much less and therefore be more stable from firing to firing. Now, this presents some interesting questions. Well, why aren't all cartridges designed that way? Well, that's a good question, because they would be if the people that designed those cases were modern cartridge designers. Now, if you look at the cartridges that have been developed in the past few years, you'll see a common recurring theme is that we have the shallowest shoulder angle that we're seeing is about 30 degrees, and some cartridges, like a 6GT, having a 35-degree shoulder angle. People are waking up to the fact that, hey, this cartridge stability thing is a big deal. And then two, how are propellants and the pressure curve characteristics of the propellants that we're using with the popular bullets that we're using in those cartridges those steeper shoulder angles are producing some phenomenal results and some extremely stable performance. So this is all a very good thing. But as it pertains to brass flow itself, the cartridges are going to vary dependent on brass manufacturer more than they would anything else, because some manufacturers have a tendency to produce relatively soft brass that will not take much in terms of pressure, so it'll be very hard to get the velocities that you're after with them. And then their firing to firing stability will also leave a lot to be desired, because as you shoot through your various firings and subject them to cycle after cycle, they will drift apart from each other in the batch. So let's say you've got 100 cartridge cases in a batch that you're processing, and you fire them one time. Now we know from my previous videos that you have to fire the case more than one time to get it to represent a mirror image of the inside of your chamber. And this is due to the elastic properties of the brass, the fact that it will spring out and fill the case or fill the chamber completely and then shrink and contract, allowing you to extract the case. Well, during that event, the brass will flow, and as it flows, the uniformity of the brass will change, because at the beginning, they're all manufactured roughly in the same process, and whatever uniformity the manufacturer has been able to achieve is about what you'll have to work with. However, you fire them one time. Now, let's say, due to the fact that there were some minor uniformity issues with maybe 5% of your cases. Well, that 5% of cases will react differently. Let's say that in that 5% of cases, so out of 100, we're talking 5 pieces, they will have a slightly different uniformity. Let's just say one of the uniformity problems is the neck thickness. So that's the material thickness from this side of the case to the other side of the case. So if we were to take a micrometer and measure right here on this side of the brass, maybe we would measure a thickness of 15 thousandths. Whereas when we measure on the other side of the case, it would be 14 thousandths. So a 1,000th inch thickness disparity from this side to this side. As the brass flows, it's going to flow more on the skinny side. So the side that's thinnest is going to grow more. There's going to be more brass flow per cycle on that side of the case than there is on the other side of the case. The thickest side is going to resist that movement and flow. And over time, without trimming, you can see your case mouth start to slant like that. And you can actually see it with the naked eye, and you can most certainly measure it. So when you try to measure your case, you'd stick it in here and you'd put it flat. You'd put the base of the case flat against the one side of the jaws, and you'd go to the other side and then you'd spin it, and it only contacts one side. It's not equidistant. Now this is a brand new case, folks, and you can see that it wants to pivot around this one side of the case. As I am putting pressure on this, and it wants to pivot on one side. So here's a brand new case. This happens to be an ADG case, and one side of it is longer than the other. Now, I guarantee you, if I were to take a micrometer and measure the thickness of this neck from one side to the other, I would find a thickness disparity as well, because during the drawing process, that material did not flow evenly, and there was too much tolerance available in their tooling that allowed that disparity of thickness to exist. That disparity of thickness does not just exist in the neck, it exists down the entire length of the case. Now, this can be remedied to some small degree by neck turning. We can turn the thickness and improve upon the thickness disparity that we see here. So maybe we can bring it to within 2/10,000ths of one side to the other. That will somewhat uniform the flow, at least up at the neck. Now we can't get inside the case, and we can't turn and uniform beneath the neck. once we get down on the shoulder here, the angles change, and I mean, it's hard enough to hold and turn the neck by itself, because oftentimes the case mouth will be slightly different diameter than the bottom of the neck. And so there's enough problems there to begin with. But we can overcome a lot of this problem by using correct sizing dies, or sizing dies that are extremely modern and forward thinking, like the short action customs dies with their incredible, unique bushing geometry. So, staying on point here, this brass flow is a huge deal. How the brass flows and moves is going to be dependent upon the pressures that you exert on it, and you can't control the metallurgy, you can't control what they made the alloy out of, you can't control their drawing process or the equipment, so what you've got is what you've got. Now we have equipment that can improve upon it should there be an issue that we can fix. Now what can we fix? Well, as I previously mentioned, we can turn these necks. We can turn the necks and uniform the thickness of the case at the top. Now that's a good idea if there is, let's say, more than 5/10,000ths of thickness variance from side to side. If you're seeing more than that, well, that might be a good idea to turn that case. If it's less than 5/10,000ths, you probably won't see a huge benefit from it, but if it'll make you feel better and you have the equipment that can effectively improve upon the 5/10,000ths, and you can get that down around 2 or 2/10,000ths or so, well then maybe you would still like to do it, because the better we get this, the more stable our brass is going to be from firing to firing. Now, as it pertains to heavy bolt lift and what we're feeling there, we're getting into a different discussion there, because here, that heavy bolt lift can exist no matter how uniform or not uniform the brass thickness or the shape of it, any of this. It's really irrespective of that. We can have heavy bolt lift destroy our cases, and that will be an unrecoverable thing regardless of how uniform we've made the case mouth or most any other factor on here. So when you consider for a moment, when you feel heavy bolt lift, what's happening is that brass is flowing and moving, and it's doing so at a rate that goes beyond its elastic deformation capability. So the elastic movement that the brass has, as the name would denote, it moves and then it springs back a little bit. Whereas plastic deformation tends to be where it deforms and does not come back. So thinking for a moment about this plastic deformation, when you have plastic deformation and something moves and is stuck there after that, that's what's taking place when you feel heavy bolt lift. Because we've pushed the brass casing beyond its ability to spring back. So we've basically killed its elastic deformation capability. Now, a lot of you are saying, well, if that happens, I'll just set my sizing die back and I'll fix it. No, it does not work that way. Unfortunately, I wish it did, because we could salvage a lot more cases. And we'll get into in a moment why it's so important that we don't allow this to happen as it pertains to our ability to actually hit our targets. The plastic deformation happens because the thickest and least likely to have an elastic property portions of the case have expanded. Down here in the case web area and base area, the brass is thick and it's also not been annealed as the top of the case has. Now there might have been some annealing during the manufacturing process just to get it to flow right and behave correctly in the equipment, but at some point they stopped subjecting this part of the case to any sort of annealing. They want the hardness of it. They want it to be really hard, but not so hard that it's brittle and easy to fracture, because it still needs to act like a balloon and capture that pressure and hold it in the chamber, not allowing it to escape. This last little portion of the case head back here is actually just free hanging out the back of the chamber. There's nothing supporting it whatsoever. So it has to be very thick there in order to counter that movement. So when the case has plastically deformed and has no ability to elastically spring back, the top of the case might have maintained its elasticity. The bottom of the case, however, has expanded to such a degree that it overcame the elasticity that the case had at the top. And so what happens then is the case gets wedged in between the shoulder and the bolt face. So the shoulder here gets pressed forward into the shoulder of the chamber, and then the base gets wedged against the bolt face. When that has happened, the brass is ruined specifically because now that the brass has plastically deformed, there's no mechanism to bring it back into elasticity. If we were to resize this case that has experienced heavy bolt lift, and we leave the die at the same setting as we resize another case that has not been subjected to this pressure and has not plastically deformed, it still has this elasticity, you would find a different headspace measurement of the two cases. So we run this one through the sizing die that has had too much pressure. We run the next one into the sizing die that has experienced normal pressure, and the headspace will be longer on this one than the other one. The reason being is it's not going to move in the same way as the other case anymore. The case has been damaged in an area that cannot be repaired. Should we be able to anneal it, we would be able to repair it, but we cannot anneal it. If we anneal it, we will soften the areas of the brass that are supposed to be hard and render the brass not only useless, but terribly unsafe. So once you've experienced heavy bolt lift, you cannot rescue that case. And even if you could, you have no motivation to do so, because that case will never shoot like a different case that has been subjected to normal pressures that the brass was manufactured to be able to handle. So even if we could bring it back, we have no motivation to do that because it will never again behave, flow, or shoot the same way as a case that's not been subjected to that pressure. So if you were to try to tighten your sizing die down and just bring that shoulder down a little more to make it fit back in your chamber, you're actually contributing to further damage of the brass. Because not only will it not react the same way as a different piece of brass that did not have heavy bolt lift, and it will never react the same way again, you're also going to be putting a tremendous amount of force, because in order to fix the case, you have to overcome the plastic deformation and the elastic deformation that you've seen. So you'd have to actually, like say you wanted to push the case shoulder back 2 thousandths. Well, on a normal case, you could just push it back about 2.5 thousandths, and the spring back would bring you back up to about 2 thousandths or so. Well, here, in order to achieve that, you're going to have to push the shoulder back roughly about 4 thousandths or more, because you have to overcome the plastic deformation and the elastic spring back tendency of the top of the case. And when you do that, you transfer all of that energy down here to the hard and brittle portion of the case, down in the case web and case head area. When you fire that case subsequently, you're leaving room, because of course we need to chamber it, so there's going to be some room in the headspace, and it's going to subsequently grow again. Now, if subjected to extreme pressure again, it will of course be much worse this time, and you'll have to squeeze that sizing die down even more. Now, some of you have probably experienced this, where you set your sizing die up and you fire maybe 2 or 3, 4 firings, and then you come back and all of a sudden you can't chamber the rounds that you've created because the headspace is too long. This is why that's happening. You're actually running too much pressure for those cases, and you aren't allowing the plastic deformation to be overcome without squeezing that sizing die down more. Now, this is part of the reason why I recommend, before you run your entire batch, after you resize a case, grab some rubbing alcohol and a cloth, wipe the lube off of it, try to chamber it back in your rifle. If you can, well then you're good to run that whole rest of the batch. If you can't, well then you know you've got a sizing die adjustment that needs to be made to get those cartridges back in the rifle. Do this before you load your entire batch. So every time you sit down to size 1 or 2 or 5,
and then stick them back in the chamber and make sure the bolt closes effortlessly to ensure that you're not going to run into that problem. Because it's very easy to fix that problem with an empty case. It is not easy to fix that problem with a loaded round. Another thing to be aware of is the fact that, hey, when we fire these things, we're going to be trimming this brass off. Now, how much you're trimming off each time and the nature of how the brass is growing can give you some indicator of the quality of brass that you're working with. Because if you're trimming a tremendous amount each time, and I'd say the tremendous amount would be like 2/1000ths or anywhere close to it, that is a per firing I'm talking, so that is a tremendous amount of brass flow. Anything approaching that or more than that, that's some very soft brass, or you are hot rodding your case. Now, this is a very common tendency among shooters, especially shooters that spend a lot of time on the internet and forums, because the vast majority of shooters are pushing their cartridges way beyond what they're supposed to be at. And I get asked all the time, Greg, how do you have such amazingly consistent performance out of your rifles? I've never seen anything like that in the world. I can grab my rifles, and rifles I haven't shot in 6 months, grab them out of the vault, lay down and shoot, and just crank out these tiny little groups and right on point of aim. Big reason for that is because I'm not over stressing the brass. I'm looking for a tremendous number of firings out of my brass. And I only choose cartridges to shoot where I can find good brass. So if Alpha OCD or LAPO cases are not available for the cartridge, I tend to not even try to use it. Because I know that the other brass manufacturers, they struggle and have a tremendously difficult time producing cases that are of the pedigree that I'm searching for in the kind of stability that I'm after. So as you're considering this, know that the metric for how you set your load up, the metric for how you're detecting pressure, is largely dependent on how many firings you can get out of a single case. So if you were to load and fire just one case, how many times could you do that before you'd run into a problem? Now, you fire it maybe 3, 4 times, whatever it is, until you feel the round not being able to go back into the rifle. Now, I have a previous video talking about headspace and how it applies to primer seating depth, and I talk a lot about this in that video, so go check that one for a refresher. But the long and short of it is that eventually this case will be a mirror image of the inside of your chamber, and you'll need to set your sizing die to bump the shoulder back ever so slightly. So when that happens, you set the shoulder for maybe 1.5 or 2/1000ths of bump, and the cartridge will go back in the rifle. Well, how many times can you fire the case at your chosen load and still leave the sizing die set up exactly where it is? Because if you have to change the sizing die in order to get the cartridge back in the rifle, you know that the brass has moved past its elastic deformation property and has plastically deformed. When that happens, you'll have to adjust the sizing die in order to get it to go back in the chamber. When you see that happen, you know that, hey, that brass is done for because it's not moving correctly anymore. And yes, if you wanted to, you could set the sizing die to push it back a little more and gain a few more firings out of it. But folks, why would you want to do that? Because you know that the brass is not behaving correctly anymore. So it's just an uphill struggle from that point. It's going to constantly be fighting back against you. All of your efforts to provide the maximum accuracy and precision downrange, that brass is going to be fighting against you every time. Because each cycle you put on the brass is going to increase the disparity that you see from one firing to the next and one case to the next. On the first firing, let's say we have maybe 5% of the cases that will come out of the mean, meaning they won't be behaving like the rest of the 100 pieces anymore. Well, when we fired again, we maybe would have 5 more that would come out. The higher pressure you run, the more on the edge of the brass's capability you run, the more cases that will come out of the mean each firing. Whereas if you stay well beneath what the brass can take, then you will not have any cases coming out from firing to firing, with the exception of those that are created by the circumstances that you find yourself in when you're shooting. And what do I mean when I say that? If you're shooting in the rain and you have wet ammunition, the water will be on the case, you chamber the case, fire it, the water is not compressible. So it's going to take up space in the chamber, and it's going to make like you have a smaller chamber than you actually have. Well, you've still got the same amount of propellant in there. So it's going to create higher pressure. Now, if you're mildly on the edge, well, that's going to push that brass beyond its limit, and you're going to feel heavy bolt lift, or you're at least going to see some pressure signs on the base of the case or the primer. When you see that, you know that, hey, that case got pushed a little hard, a little too far. It's not going to behave like the rest of them anymore because you pushed it beyond its capabilities. Another thing that can happen is cleaning chemical residue in your chamber. You can have that take some cases out of the mean. When I say mean, I mean average, right? Out of the average performance. So if you're out shooting and you cook a round in the chamber, let's say you put 15 rounds downrange in quick succession, your barrel's very hot, number 16 goes in the chamber and the shot's not there, so you just wait and then you fire. Well, that hot round, that as far as the temperature, right? The temperature in the barrel is going to cook that powder. It's going to make it react differently than a cold chamber would. That's why it's important to not do that. If you're running a hot rifle and the shot's not there, you don't even chamber the round. And that's why maintaining your natural point of aim is so critical from shot to shot if you find yourself in that situation, because you need to be able to close the bolt without influencing natural point of aim and violating natural point of aim, and get the shot made very quickly before the powder has a chance to get scorching hot as a result of being placed into a really hot chamber. These are just a few aspects that can cause rounds to come out of the mean of how the performance of your brass casings in the entire lot of ammo that you're using will behave. There's many others, basically unlimited scenarios that could potentially do it. But the bottom line is, if you do have a case that happens to, it's not going to behave like the rest of them anymore, and you need to cull it out. Heavy bolt lift or pressure signs on the base of the case or the primer in the form of ejector wipe, ejector ring, or cratered primers, flattened primers. There's a whole article on pressure signs and how to read them on the library section of the Primal Rights website. So I encourage you to check that out if you haven't already. But if you have that happen, you have to cull that case out because it's not going to behave like the rest of them anymore. And as a responsible rifleman, if you're truly a student of the discipline, you're going to want to hit your target every time. And so you cannot expect these cases to behave the same as the rest of them. They need to be pulled out of rotation. So now you know what is happening when you feel that heavy bolt lift, and you know that once you feel it, you can't fix it. So it's very important to stay away from it. And the main way to do that is to make sure that you're running loads that your brass can handle. And the way you know whether or not your brass can handle it is that you reload the same piece of brass multiple times and ensure that you can get the number of firings that you want out of it. And you take measurements after each firing. Because if your brass is going to be stable across multiple firings, and you typically want a batch of brass to last you the life of a particular barrel, if you can accomplish that, that's good. And the primary method is just taking measurements. So you would fire the case, and you'd resize it subsequently, and you always want to evaluate your sizing die and make sure it's not overworking your brass, and compare the numbers that you're seeing on the brass before and after your resizing. And obviously that's a separate topic because that's just kind of how you set up your sizing die and evaluate a brand new sizing die, a new chamber and a new barrel, things like that. But in terms of brass longevity, what you're looking for is measuring the overall length after a cycle. So after you pull it out of the sizing die and out of the tumbler so it's not all greasy, you take a measurement, and it's at that point that I would typically trim. And so I'm finding how much I'm getting the brass to grow between firings, how much I'm trimming off between firings on average. And by getting a knowledge of how much it's moving, I can determine whether or not the brass is good or bad. I correlate that with the performance on target to see across the entire batch of brass how many flyers I've got. If I think that the brass is stable and not causing those flyers, I can evaluate all this together. So loading a single piece or maybe 5 pieces of brass and seeing that you can get the adequate number of firings on them is a very easy and important way to discover if you've got a good batch of brass. And it's also the only practical way that you can see if you're running a load that is mild enough to really allow the brass to be stable from firing to firing. Now, the higher the quality of your brass, the easier that this is going to be. So folks, I cannot stress this to you enough. If you can get Alpha Munitions OCD cases for the cartridge that you're shooting, you should do that, because that is the most stable brass that I have ever worked with in my career to this point. And that stability lends itself to a accuracy and precision from firing to firing that is unrivaled. I haven't seen anything like it. So stable performance by allowing the pressures to be where they need to be and have the performance that we expect to see out of that particular cartridge, that component combination, but then 2, making sure that the brass is so strong and so stable that even though we're running right where we're supposed to be, we're getting the advertised performance out of the cartridge. We're not torturing the brass from firing to firing and causing a disparity of performance in the group of cases that we're shooting. So the number one way, the most practical and easy way for you to make sure that you're not being affected by this problem is to purchase high quality cases. So Alpha OCD, that's my number one choice. Lapua cases comes in a close second behind that. Basically everybody's fighting for third place at that point. And some of them are real bad folks. Some of them that have a very good reputation and get recommended a lot, they're actually producing some very poor brass. And what's happening is there's a lot of people that are buying a lot of stuff that are not doing a lot of shooting, and they're not evaluating things properly in the vein that this video is talking about. So buy good brass. Now, the second way is to make sure that you're not running hot loads. Folks, there has never been a situation in my entire career where I've been able to horsepower my way to accuracy and precision. It just does not matter. The extra 25 or 50 or 75 foot per second that you could get by running in the high node on a cartridge right up against the level of performance that the brass will be able to take, the closer you are to that datum, the more of your individual cases are going to separate themselves from the average of your cases, and the more that's going to happen each firing. And so you're not going to get a performance improvement downrange by that 50 or 75 or even 100 or 150 foot per second. That's going to be worth it by sacrificing the stability of your cases. So instead of chasing that performance, you have to operate within the level of performance that your particular brass, your particular barrel, your cartridge component combination is going to dictate. And the only way that you're going to gain that understanding is by maintaining a good, solid working relationship with your brass, by measuring and understanding all of the things that I've outlined in this video. So stay away from the hot loads. They're not going to benefit you. You want to be working with loads that are very stable. That stability is what translates to real world accuracy from range session to range session, or from hunting trip to hunting trip. The stability and the consistent performance, that very fine level of consistent performance that a real rifleman, a real student of the discipline is after, comes largely from your understanding of this principle: maintaining a solid, consistent batch of brass. Now, there's tons of other topics that we're going to get into in future members-only exclusive content for our apprentice and student of the discipline members that are going to rely on your knowledge of this subject in order to understand things like bullet to case neck relationships, your understanding of the brass as we've explained it here is going to be critical to you making the right decisions as it comes to bullet seating pressures and various other concepts that rely on the brass as its source of uniformity. Now keep in mind here, folks, this brass uniformity is so important because once we're done working our brass, once we've done all of our brass prep steps, what we've got is what we've got. And so when it comes to primer insertion, the static powder column configuration, and how our bullet is seated and the nature of how uniform that is, it's largely going to be a function of our understanding of the brass and our understanding of the correct processes and procedures to work with that brass to maintain the uniformity that exists from the factory and in sometimes improve upon that uniformity as well. To recap, the two primary ways that we get around the problems that we face by having brass pull away from the mean in our batch is to run mild loads in the low node, which is typically where I've seen the very best performance both from an accuracy and precision standpoint, and to purchase high quality cartridge cases, the highest quality that is available. If you skimp here, if you try to pinch pennies here, you might as well relegate yourself to a substandard, mediocre performance level because there's nothing that you're going to be able to do in the rest of the process that will bring you the uniformity that a extremely uniform batch of cartridge cases will bring. So do not underestimate the importance of this. It is probably one of the most important lessons that I as a shooter have learned in my entire career. A quality batch of cases is number one in terms of my priority when I'm selecting my cartridge components. You can use a great batch of cases and you can work with bullets of all different kinds and powders and primers of all different kinds. But folks, this brass issue is huge. It cannot be overlooked. Well, thank you for watching, and remember, those of you at the apprentice or student of the discipline level watching this video, if you have any questions and would like to have a higher level discussion about this topic, you can feel free to give me a call anytime at the Primal Rights number on the website. And if we need to, we can jump on a video call subsequently, but I'd like you to initiate that call through the normal Primal Rights number on our website first. That number is 605-554-1911. Now also remember that the success of our mentorship program that we've instituted via our YouTube channel is largely dependent upon you guys. Because if you don't tell anybody about this, if you don't share your positive experiences here, if you do enjoy this content, then we won't be able to gather new members, and eventually this will lose steam, and I'll have to find a different way to present this wonderful discussion. So please, if you do enjoy this content, please tell your shooting associates about it. Get them to come here and sign up and become members themselves. We're going to be releasing a bunch more content just like this video and even more exciting topics in the near future all throughout this next year. So if you have a friend or a shooting buddy that would benefit from this type of discussion, please send them over and get them signed up as an apprentice or student of the discipline member. And I thank you very much. And again, if you have any questions about any of this, just give me a call. Let's have a great discussion.